Hello, welcome to ASA Photography. My name is Daniel. It's been a while since I posted the last video. The reason is we have having excellent weather, so I have been photographing quite a lot. The last week the weather has been not so good, but I have been able to capture almost 150 hours worth of exposure. About half of that time went quite well, good subframes. I have been making a list of what I need to improve. One of those things is to being able to open the roof just a bit more, about 20 centimeters. I want to be able to point my telescope a couple of degrees further down in the eastern direction. I've also been adjusting the secondary mirror holder. It holds collimation quite well, but I need to having it just a bit more sturdier, so I don't have to collimate that often. I will show it just in a minute. I have also been capturing about 30 hours of the Flaming Star Nebula. I have previewed one of the H-alpha subs for you in the last video. Today you are going to see the full image. So one of the things I need to adjust is remove the scraper. It's also cracked one of the wood plates there. The reason is that this almost hits the stop of the rail, so I need to remove that one to be able to push the roof out further, about 20 centimeters. So I'm going to do that in a later video, I presume. So that's one of the things I need to adjust. The other thing I need to adjust to be able to push the roof further is one of these magnetic sensors. You can see that that is connected to the roof controller. I will probably show you how all these things works in a later video. I also have one magnetic sensor here. You can also hear when the relay is changing state for a photographic sensor. So that is also going to be done in during the spring here when it gets too light to image. I'll also be doing one of my most analog automated processes for my observatory. I was thinking of how to manage the flip option for the cover of my telescope, but I actually just tied a string to the wall and when the telescope is slewing upwards to pass the reference mark on the encoders, it just pops off like this. I'm particularly satisfied with that solution, so it's 100% proof and it have never failed so far. I don't know if you guys can see this, but I have changed the center bolt for the secondary holder and attached a spring, quite heavy spring, to adjust for temperature shifts. I have been fiddling with different kinds of springs, the one that followed the telescope, and also with no spring, so attaching the center bolt like directly to the secondary. But it holds collimation for a couple of days and with temperature shifts, and then I have to recollimate. So I'm going to try this new method and see how that works out. Let's jump into the computer and take a look at how the images for the Flaming Star Nebula looks like. Let's take a look at all the images I have been working with for a while now. So let's start out with the 3 images from the different filters. So we have the O3 image. It's almost no data at all to work with. I should mention these three first picture here is first selected via the tool. I believe it's the batch pre-processing script, where I sort the images from how well focused the images are, how the signal to noise ratio is, and also the eccentricity of the stars, or how round they are, basically. So this is the O3 filter. You can see some gradients here. You can see some data here, the oxygen, but it's not much at all to work with. So let's minimize that. Let's take a look at the S2, and this is a lot more data. And I should mention, each of these filters has approximately 3.5 hours of data in them. So just compare. Almost no data in the oxygen filter, and this is the sulfur filter. It's a huge difference. A lot more data here. As you can see, the stars are nice and round, and I'm very happy to see this. You can also see some noise here. This is no editing at all done to these images as of now. And here is the H-alpha, and look at this data. The only thing I have done to this image is the drizzle, and I've drizzled all of them to get a bit more resolution, or actually a bigger picture. The details isn't affected at all. But look at this data, almost no noise. It's very good signal to noise ratio. The stars are looking superb. Nice details in the clouds. Just look at it. So what we have done is we have taken each of these filters and we have done a deconvolution. So this is the H-alpha filter, and if you compare these two together, you can make up that the stars is just somewhat sharper. I am using the deconvolution tool very carefully, and also the noise. You can see the noise is affected somewhat also, but a bit more details in this image compared to the image which not have been edited. So yeah, that's the deconvolution, and I am doing this on all filters. So after the deconvolution, we are doing a multilinear transformation. I don't know why I named it MLL, but it's multi-linear transformation, I believe it's called. I have to double check that. Multi-scale linear transformation, yeah. That is a noise reduction tool. And if you take a look at this one, which has not been noise reduced yet, and I'm going to switch to this image now. Maybe I have to have the correct zoom level as well. So here you can clearly see some kind of noise, and boom, gone. So that's the tools I am using. So in this state, we're going to combine the three filters to get a color filter, and here it is. And as you can see, it's very green, and the stars are magenta, which they are going to be when you're shooting narrowband images. But after some, so to this point, I'm using PixInsight in the linear state, and now when you are doing the permanent stretch to the images, you are working in a non-linear state. From now on, I am working with color masks, and curves and histogram transformation to get the color levels and saturation and such correct. So this state from now on is just basically what I am thinking as a good image. There's no correct or not correct. It's just the artist's interpretation, I believe. So the image I ended up with looks like this. This is a classic golden bluish one from the Hubble palette, where hydrogen is associated to the green channel, the sulfur is associated to the red channel, and the oxygen filter is associated with the blue channel. So this is it. I am quite happy with this image. Nice details, nice round stars. So I have not been working in PixInsight for over a year, so I'm I need to learn this again, but I'm quite happy with these details. The noise level is contained in an acceptable level. So yeah, this is the image, and I'm super happy to finally see that the telescope is working as it should. Please subscribe to my channel if you like these videos, and comment if you have any questions. You can also visit my Facebook page if you want to read some more on these images. Take care out there, and I'll see you next time. Bye.